Today we're going to talk about 6.2 operation of vectors. This is a very long chapter, so it'll be broken up into part 1 and part 2. So we'll come to part 1 of operation on vectors. Today we'll be talking about the addition and subtraction of vectors. So basically, how do we add vectors? I like to think of it as walking a road. So for example, on page 166 of your textbook, they actually talk about the addition of vector AB and the vector BC. Okay, so how does it work? I have taken the liberty to draw the vectors AB and the vectors BC. So for example, now I start, right, if I'm trying to add vector AB to vector BC, first I will take vector AB. You notice I'm just moving it around, so I just plug it there first. So imagine that if you're walking, so you started from from point A, you walk, then you are at point B. Now what do I do now? I need to continue walking. So since I've walked from A to B already, now I'm adding the next road will be, or the next vector is BC. So I take here, so do not forget that we ended up here just now at point B. So what I'll do now is this. I'll take the vector BC, I join, okay, down here. So basically what I have done is, if you imagine the road analogy, I walk from A, then I'm at B, then I'll continue walking, and my endpoint is C. So basically I started at A, I ended off at C. So what is a faster or shorter way for me to walk from A to C? I could walk, right, a direct line, okay, from A to C like this. Okay, then I draw two arrows there. So basically what I'm saying is the vector AC is the resultant of adding vector AB plus BC. So as you can see from above there, AB plus BC is equals to the vector AC. So it can be looked upon as the shortest way for me to walk from A to C. So instead of walking from A to B, B to C, I can just directly walk, right, A to C. Okay, now to illustrate this point, let me just try out a few questions with you. Okay, so in try 8 on page 168, they show three vectors P, Q, and R. Okay, let me draw the squiggly lines for you. So it's P, Q, and R. So now they say that they want to add vector P to vector Q. So I'm doing part A now. So to add vector P to vector Q, first I will take vector P. Alright, so let me draw vector P. So vector P is 3 units, so I just do it here. Okay, so vector P is 1, not 3 units, okay, 1, 2, 3, cuts across 3 squares. Okay, this is vector P. Then I want to add it to vector Q. So don't forget, just now I started from walking here, and then I am down here now where the cross is. So I will just plunk vector Q down. Okay, vector Q, it goes across 3 squares like this, 1, 2, 3. So the road that I walk, right, is along vector P. Then after I continue walking along vector Q down here. So basically the resultant of vector P plus vector Q, the faster way, instead of me walking from here and ending up here, the faster route is like this. So therefore the resultant in this case, I will draw in orange. Alright, this one in orange, the resultant, this is vector P plus vector Q. Okay, then they also tell us that they want us to represent it as a column vector. So in this case, the column vector is 0 and -2. Okay, I will not revise column vectors. We have done that last week already. Okay, you can pause the video if you want to practice drawing it yourself. If not, I will move on to the next portion of vector R plus vector P. Okay, similarly for vector R plus vector P, what I can do here is this. First, let me draw out vector R first. So vector R, it cuts across 3 squares. So vector R, let me just draw it here. Okay, I think I'll run out of space. Let me find a better place to do this. Okay, down here. Okay, I start from down here. So if I draw out vector R, okay, this is vector R. Then I'm adding it to vector P. So if I add it to vector P, it goes like this. Okay, so just imagine I started off here. I took the road vector R, then I go down to vector P, then I end off down here. So what's my resultant? The resultant is from here, I can directly walk to here. So this one, okay, will be the addition of vector R plus vector P. Okay, let me draw that in orange for you. Okay, it's down here like this. So this one here is the addition of vector R plus vector P. Then if I express it as a column vector, what I get is 1, 2, then minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. So if I were to write it down, okay, vector R plus vector P will actually give me 2 and minus 6. Okay, let's move on to the next example. Okay, next example we have class activity 1. Okay, so let's just do this. We don't have class now, so I'm the class. So I'll do the activity now. Okay, so basically what they want here is this: draw the sum of AB plus BC. So if I just go from here, AB plus BC. So the sum in this case will be AC. So let me just draw it out there. Alright, so they say that they want the sum of AB plus BC. So this is the sum there. So let me just point it out to you. It is down here. Now, represent AB plus BC using a single vector. So that single vector here in this case will be AC. Now, they say that they want to express AB plus BC in terms of vector U plus vector V. So vector U is simple enough. There's vector U here. But how about BC? You notice we don't have BC. It's not written. But notice that BC is actually the same vector as AD. Okay, so B to C, magnitude same, direction if it goes upwards. Okay, so if AD is vector V, BC will also be vector V. Hence, AB plus BC can be rewritten as vector U plus vector V. Okay, now let me just erase the things and I'll do part B for you now so I don't confuse you. Okay, for AD plus DC, okay, same thing. So I'm doing part B now. AD plus DC. The sum will be like this directly. It will be A to C. So I will say that the sum of AD plus DC is also equals to AC, same as just now. So let me just draw that. I have drawn this in orange now. Okay, now represent AD plus DC is a single vector. So notice that in this case the vector is AC. Notice it's the same as what we did in A part 2. So AD plus BC. Okay, so AD plus DC. How we're moving here is from A to D. There's vector V. D to C is vector U. Why is it vector U? Because if DC and AB are equivalent vectors, so if AC is U, DC will also be U as well. So therefore, I say that AD plus DC will be equals to vector V plus vector U. So from the results in A and B, what's the relationship between U plus V and V plus U? We can see that both of them, in this case, they are equals to AC. Hence, I will say that vector U plus V is equivalent and equal to vector V plus U. Okay, now I am on page 169, still in the class activity. Draw the following sums in diagram. Okay, so what we have is AB plus BC. So AB plus BC, in this case, let me draw this in red this time. AB plus BC will be equals to the vector AC. So So therefore, down here I say AB plus BC equals to AC. Now, for the next part, number 2, down here, AB plus BC plus CD. So AB plus BC plus CD, what happens here is this. So we are moving from AB plus BC plus CD. Okay, so the resultant vector is actually AD. So I'll write down that this is equals to AD. Okay, let me just draw it out for you. Okay, this one is the vector AD. So now they want us to express the vectors U plus V plus W as a single vector. So as a single vector in this case, how we're moving is U plus V plus W. I started here, I ended here. So as a single vector, it can be represented by the vector AD. So hence, for this part, I here, I'll say U plus V plus W is equals to the vector AD. Okay, let me just erase the diagram so it's easier for us to do part B now. Okay, now for part B, they say draw the following sums of BC plus CD. Let me just draw it in another color. Maybe let's pick green. Okay, so now I'm doing BC plus CD. The resultant vector in this case will be BC plus CD will give me the vector BD. So this is equals to BD. Then similarly, AB plus BC plus CD. Alright, let me just erase this. Okay, let me do this in yet another color. It's great to have so many colors. I'm going to do this in purple. Okay, so I'm doing this. AB plus BC plus CD. So my resultant vector is down here is also equals to AD. Hence, for this case, AB plus BC plus CD is equals to the vector AD. Similarly, express U plus V plus W as a single vector is equals to the vector AD. So just like what we did in the previous slide, what is the relationship between this U plus V plus W and U plus V plus W? We can tell that they are the same. So if I write it down, vector U plus vector V bracket plus vector W is equivalent to vector U plus vector V plus vector W. They are equal vectors. I'm now moving on to page 170 of Try It 9. So what they want is vector QP. Okay, I'm just going to use I'll use different colors here. So vector QP, I'll use purple. So vector QP is here. Alright. Vector QR, let me use orange. Vector QR is down here. Okay, and vector SR, let me use another color for vector SR. Let me use red for vector SR. Vector SR is like this. So if you notice, okay, down here, the three vectors, they don't quite join up. So for example, if I start off, alright, okay, oops, I forgot the colors. Okay, this is red. Okay, so if I were to try to join it up, okay, if I start with QP, so if I move from Q to P, I end off here. Hey, there's no more road to follow. What happens? Okay, this QR is on the other side of the diagram. So if I move from Q to P, I'm stuck. I can't just fly over here and continue walking, can I? Okay, so what I can do here is this. Why don't I find an equivalent vector to replace QR? So what do you think is an equivalent vector for QR? So my first question is to you is this, okay? QR, the equivalent vector, it will be PS. Why? Again, same thing. QR, the magnitude is as such. So QR and PS have the same magnitude and they have the same direction. So instead of writing QP plus QR plus SR, I can actually write it down as vector QP plus vector PS plus vector SR. So let me just redraw the diagram. Okay, this one is in orange now. So what I can do here is this. Let me erase vector QR. An equivalent vector for QR is PS. So let me just draw it out in orange there. Okay, so this is the vector down here. So now you notice I have actually linked up the three vectors. So from Q, I can move to P, that's QP plus PS, then plus SR. So I end off down here. So what is the single vector that represents QP plus QR plus SR? It is this vector down here, which is QR. Hence, the resultant of the addition of these three vectors is equals to QR. Okay, let me just draw in a diagram for you. It's down here. So I just repeat one more time. If you start from Q, you move to P, QP plus PS plus SR. Okay, instead of moving one whole round, the most direct way is I start from Q, I end off at R as well. So hence, that is the resultant vector of QP plus PS plus SR. Okay, now we are going to move on to class activity 2 now. Okay, so for class activity 2, the first question they ask is express the vector AB plus AC as a single vector. So you should be experts by now. AB plus BC as a single vector. If I start from here, I end here, the single vector is simply the vector AC itself. Hence, AB plus BC as a single vector is the vector AC. So now they say describe the overall movement, okay, of the helicopter by a single vector. It is once again AC. Okay, what is the relationship between the results in A, B, and VC? They are equal. Okay, we move on to page 170. And this one's a bit tougher. Okay, draw a vector representing V, X, and the vector V subscript Y. Okay, so now if you notice, once again we run the same problem. Vx is going this way, okay, and Vy is this way. However, okay, if I were to draw a vector representing Vx plus Vy, what I can do here is this. So in red color, I have Vx, which is this. Then in orange color, I have Vy. Okay, why don't you take a short moment now, okay, and go and think about it. All right, where is my resultant vector for this Vx and Vy? Okay, are you able to draw the resultant vector? Okay, let me draw it out in black for you. The resultant vector, since I start here, I'll end off down here. The resultant vector in black color is shown there. And this is Vx plus the vector Vy. Okay, now, if we want to describe the velocity of the golf ball, okay, so the velocity is given by the sum of the two vectors. Vx plus Vy. Okay, it is represented by the hypotenuse of the triangle shown. Okay, and that is that for class activity 2. We are moving now to page 171. We have try it 10. Okay, the diagram, the angle between two forces OP and OQ is 115 degrees. Okay, now find the magnitude of the resultant force. What we can do here is this. I'm going to redraw the diagram. So if I'm trying to add OP plus OQ, so OP is this. Okay, notice that OQ is on this side, all right? So what we can do is to transplant, so to speak, OQ to join up. So if I'm at O, I walk to P, I'm down here. What I need to do is transplant OQ so that it is down here like this. So if I were to redraw my diagram, what I have is OP plus OQ. Okay, so the one in orange is OQ. All right, this is 12. All right, and then where's our resultant? The resultant is the one in black over here. Okay, let me just make the diagram a bit bigger for the moment. Okay, if I notice this, okay, now I need to calculate the magnitude of the resultant force. So basically I need to find the length of the vector there, okay, the one in black. So what do I do? Okay, first you will notice, right, what can I say about this vector in this OQ and this OQ? They have the same direction, so therefore they are parallel. So if they are parallel, what I can say is this angle here is 115 degrees. Since these two lines are parallel, what can I use? I can use the sum of interior angles. So this angle over here will give me 180 minus 115 degrees. So what I have here is 65 degrees. So what I can do here is this. Let me just pull up the pen. Okay, then I can label this as 65 degrees. Now, if I have the unit 15 here, I have 12 here, I have 65 degrees. I'm trying to find the length, okay, or the magnitude in this case of this vector. What can I apply? So if you can recall for trigonometry, we have one side, two sides, three sides, and one angle. I can apply the cosine rule. Okay, so now I will say this by cosine rule. The magnitude of the vector, okay, let me just call this the magnitude, all right, of the resultant force, c square, okay, is equals to 15 square plus 12 square minus 2 times 15 times 12 times cosine of 65 degrees. So if you use your calculator, you'll find that the value of C is 14.726. Correct the 3SF, C is 14.7 units. So therefore, in this case, let me just erase this. The magnitude of the resultant force is equals to 14.7 units. Okay, now I'll show you some examples from exercise 6.2. This can be found on page 183 of your textbook. Okay, so it will just reinforce what we have actually learned for the addition of vectors. So first and foremost, what I'm trying to find is draw a vector that represents A plus B in the following cases. So what I have is vector A plus vector B. Very simple here. The resultant vector in this case, A plus B, since I'm walking from A, then I walk to B, this is where I end up. I started off here, I walk until I reach here. So my resultant vector in this case will be A plus B. Okay, now right here is A plus B. Similarly, A plus B, this is the one where we have to move the vector again. Here is A. If you walk from here until here, you're actually stuck, okay? You cannot jump and go down here. So what I need to do is I need to take B and I move it over here. So I can draw vector B over here. So let me just draw it out for you in orange. All right, vector B. Okay. Okay, vector B will look like this. Okay, this is vector B. So the resultant in black is A plus B down here. So I will represent my resultant with two arrows. So this resultant is vector A plus vector B. Okay, this one, okay, A plus B. So A and B, let me just redraw both of these vectors. So for part C, I start with vector A. Let me draw it in red. Okay, so vector A is like this. Then if I want to add it to vector B, I draw it like this. So my resultant vector, I just superimpose over this. The the resultant vector of A plus B actually goes from here all the way to here. Okay, the diagram is not so straight. Okay, so let me just draw freehand. A plus B is like this. Okay, this thing really doesn't like me. Okay, A plus B is like this. This is the resultant vector, A plus B. Okay, now for part D, A plus B. Okay, this one is a bit tricky. So let me just help you here. A plus B actually works like this. First, I will draw the vector A. Okay, so vector A, I start from here, I end here. Then if I plug and put vector B will move downwards. So vector B will move down and down like this. So basically just follow how I go. Okay, so vector A, it moves like this, then I end off here. Then vector B is moving downward, so if I pluck it, okay, vector B actually moves downward this way. So if I start here, I end off here, my resultant vector is actually the vector that is moving downwards. So vector A plus B actually gives me a resultant vector that looks like this. So this is A plus B. Okay, now I move on to question 2a. Okay, for question 2a, what we have here is this. They want vector A plus vector B. This calculation is quite similar to what we've done in matrices. So if I want to add two vectors, vector A plus vector B, simply I will just take 7 and 3 plus and 2 and 5. So what I'll do here is I'll add the 7 to the 2 to get 9. I'll add the 3 to the 5 to get 8. So the sum of vector A plus vector B is 9 and 8. Moving on to 2D. Similarly, 2D is asking us to add vector A to vector B. So what I have here is 3 and 2 plus negative 3 and negative 2. 3 and negative 3 gives you 0. 2 plus negative 2 also gives you 0. Hence, in this case, the resultant vector is 0 and 0. Okay, I move on to question 3a now. Okay, for 3a, draw a vector that represents the OP plus OQ and find its magnitude. Okay, let me just redraw the diagram again. So in red, okay, for OP, I have it in red, and OQ, I have it in orange. I won't explain too much. We have done quite a bit of this already. So OP will be, it looks like this. Then OQ, if I join up, okay, I can remember, can't jump back. So I join up OQ like this. So OQ is 3. So draw a vector that represents OP plus OQ. So in black, what I have is the resultant vector that looks like this. This is my resultant vector, and I call it OP plus OQ. Okay, and indicate the magnitude. So the magnitude of OP plus OQ in this case will be equals to, notice that this is actually, POQ is 90 degrees. This is 90 degrees. So if I apply Pythagoras' theorem, I have 4 square plus 3 square. Then I square root this. I will find that the magnitude is 5 units. Okay, now we will talk about subtraction. If this has been heavy going, you may like to take a break for a moment. If not, pause the video, we just carry on with subtraction. Okay, subtraction basically is similar to addition. Okay, just think of subtraction as this. So if I'm adding the vector u to the vector v, I'm actually adding the vector u to the negative of vector v. Okay, so why is this important? Because let me just give you a brief example. We have covered this before already. If I have a vector, okay, let's say I have a vector like this. If this is vector a, all right, how does negative a look like? Okay, negative a will be parallel. Okay, it will have the same magnitude. Okay, but notice that negative a will go to the different, it will go in the other direction. So basically what we're doing is we're taking to get a negative vector, we just reverse it, okay, then we add the two vectors together. Okay, to make this point clearer to you, I move on to page 173. Okay, now they say, can you draw a vector representing u minus v? So I'll just do part A for you first. Okay, so vector u, I will draw it in red, okay, and vector v, I'll draw it in orange. Okay, so now I'm doing part A. So for part A, vector u, okay, vector u is simple enough. Vector u is down here. Okay, I'm adding it to v. So let's pay attention to v for a short moment. Positive v is going upwards like this. How would you draw negative v? Negative v will of course be going downwards like this. So when I say vector u minus v, I'm adding vector u to negative v like this. So u minus v in this case will look like this. So this is negative v, and my resultant, okay, will be like this. Okay, not so nice. Let me try to draw it out with a... Okay, and this will be the resultant of vector u minus vector v. I'm moving on to part B now. U minus v. Okay, same thing. Let's look at negative v. If positive v is going upwards like this, how does negative v look like? Okay, I can draw negative v in this case to look like this. This will be negative v. Let me just focus on this part of the screen. So therefore, if I vector u, which is this, and I want negative v, I will join it up to this point here. So negative v will look like this. So what I have here is, I started here, I continue walking, I end off here. My resultant is down here. So therefore, what I have here is the resultant of u minus v is this vector over here in black. This is u minus v. Okay, now what I do for part C, same thing, u minus v. Okay, this case I may need to redraw the entire diagram, if not I'll run out of space. So u is in red and v is in orange as per normal. Okay, so I'm doing part C now. So vector u will look like this. Okay, now just think for a moment, how does negative v look like? If positive v is coming downwards like this, it simply means that negative v will look like this. This will be negative v. It's going the other way. So now what I do here is, I've already drawn the vector u down here. Now I need to draw the vector v. So if I draw the negative v, sorry. So if I draw negative v, 1, 2, 1, 2. And this will be negative v. So my resultant for part C of vector u minus vector v, once again I draw it in black, will be this one here. This vector here is u minus v. Okay, I shall move on to part D. Okay, let me just erase the top portion there. It's very messy. Okay, u minus v. Okay, this one have to be a bit more careful. Maybe 5, 6, 7, 8, and 4. Okay, so u minus v. Alright, u is already been drawn. I will leave it there. So this is vector u. Okay, minus v. Okay, minus v. If positive v is going this way. Okay, let me draw this in orange. Positive v is drawing this way, so that means negative v will be going the other way. Okay, so okay, I think I'll run out of space here, so never mind, let me just redraw this. Okay, so 1, 2, 3. Okay, this is vector u. So negative v is going the other way, so negative v will be 8 and coming down by 4 units. Okay, negative v, alright, will look like this. Okay, negative v, my apologies there. Negative v will look like this. This itself is negative v. Hence, my resultant in this case of u minus v, if I just draw it out, okay, it will be down here like this. So I'll label this as u minus v. Okay, I will move on now to try 11. Okay, try 11 is just some simple calculation. What I have is q plus vector q plus vector r. So vector q plus vector r. Let me just begin there. Just give me one short moment. Okay, so vector q plus vector r, part A. So vector q is 2 and 3 plus vector r is 1 and negative 7. So what I get is 2 plus 1 is 3, 3 plus negative 7 gives me negative 4. For part B, I have vector p minus vector q plus r. So vector p itself is negative 5 and 8 minus vector q plus r. I already have the result, which is down here. So it is 3 and negative 4. So same thing that we used to do, alright, for our vector addition. Negative 5 minus 3 gives you negative 8, and 8 minus negative 4 gives you 12. Okay, finally, I will calculate vector p minus vector p. You already know what you're going to get, but it's okay. Vector p minus vector p. Negative 5 minus negative 5 will give me 0, and 8 minus 8 will give me 0 as well. Okay, now we move on to try it 12. Okay, and try it 12 can now be found on page 175. Okay, I will just very quickly do this. I'll just show you one. Okay, then you can go and try it out. If not, the video becomes too long. I will find modulus, okay, or the magnitude of vector A. Magnitude of vector A is 2 square plus negative 6 square. So the magnitude of vector A is square root of 40. It gives me 6.32 units. Okay, magnitude of B, I'll just shortcut the working. Alright, it will be, okay, sorry, I forgot the square root, the top part. Okay, if going by the same logic, okay, for the magnitude of vector B, I'll get square root of 10, which is equals to 3.16 units. Okay, for last part, okay, of part A, first I find vector A minus vector B. So very quickly, 2 minus 3 gives me negative 1, and then negative 6 minus negative 1 will give me negative 5. So the magnitude of vector A minus vector B is equal to negative 1 square plus negative 5 square. We square root, we get square root of 26, which is 5.10 units. So now they said determine whether magnitude of vector A minus B equals to magnitude of A minus magnitude of B down here. So in this case, alright, let me just do some simple calculations. Magnitude of A minus magnitude of B is root 40 minus root 10. So where am I getting all these values? They are here and they are here. Okay, what I will get here is 3.16 units. So can you conclude if they are equal? They are not, because magnitude A minus magnitude B is 3.16 units, while the magnitude of A minus B is 5.10 units. So I can conclude in this case that this equals to this is simply not true. Okay, now we are on page 176, which is try it 13. Okay, these are the kind of questions that will be more common, especially for vectors itself. So now let us begin. Okay, identify the vectors which are equal to vector B and vector V. Alright, so now let us look at the question here. So vector B, okay, notice that vector B is over here. There are no other vectors. Some of you may be tempted to say that vector BD is same as vector CE. However, be very careful. There is no indication, alright, that these two vectors have the same magnitude or if they have the same direction. We don't know that they are equal. So, BM. Oh, sorry, my apologies there. Okay, so BD, no apologies actually, BD and CE. Anyway, I made a slight error there. BM is equals to vector B. So it's not BD, in this case it's just BM, this small portion here. So BM is equals to vector B. So which other vector is the same one? Okay, if M is the midpoint of BD, so if BM is equals to vector B, so therefore MD will also be equals to the vector B. So I can say for A, part 1, okay, what vector B, the equivalent vectors are BM and MD. Okay, for part 2 now. Okay, if I'm trying to find DE, okay, so are there any other vector? Are there any other vectors that are equals to vector V? If I have no indication wherever that vector D, okay, is the midpoint of AE, hence right, I have no idea, so I will say that there may not be any vectors. So I will say that DE itself is equals to vector V and is the only vector that is equals to vector V. Now, moving on to B, part 1, 2, and 3. So if I move on to B, part 1, A plus B plus V. So A plus B plus V, okay, I can actually rewrite A plus B plus V as equals to AM, okay, plus B. B is MD. So if you are finding it hard to follow, vector A plus vector B plus vector V, like this. Okay, that's how the vectors are moving. So I have AM plus MD plus DE. So what I'll get here is A plus B plus V. The resultant vector itself is equals to AE. B part 2, I am trying to get A minus B. Okay, so now right, let's just remember, if positive V is this, positive B is this way, negative B will be going the other way. This will be negative B. So for A minus B, what is happening here is A minus B. This is minus B. The resultant vector itself is AB. Hence, I can write down vector A minus vector B is equals to vector AB. Okay, for part 3, what they need from us is this. Let me just erase everything. Okay, A minus B minus V. So A minus B minus V. So if you notice, A minus B itself is actually equals to the vector AB. And are there any other vectors that are equals to AB? That's right. AB is equals to the vector DC. So what we have is DC, then minus V. Okay, so minus V in this case will be going downwards. So what I can say is this. I actually have, in this case, let me just write it down. I have DC plus the vector ED. Okay, now if you notice, DC plus ED can be rewritten as ED plus DC. They are equivalent. So instead of writing CM, okay, I know it's a bit confusing. Instead of saying DC, I have moved here plus ED, it's somewhere over there. Why don't I switch it around and say that I will take ED plus DC instead. Okay, so I have ED plus DC. So the equivalent vector itself is equals to EC. Okay, now we are at triad 14. I know it's a long chapter. Do take breaks once in a while. Okay, pause the video. Now, express BC and DA in terms of vectors A, B, C, and D. Let me just draw all the squiggly lines first. Okay, now first we have BC. So for vector BC, how can we actually express the vector BC? BC is here. So BC can actually be made up of BE plus EC. Is equivalent to EC. Okay, let me just put it. So vector BC can be written as BE plus EC. Okay, so if I want for vector BC, so vector BC, I can rewrite it as vector BE plus EC. So BE is not B, it's going the other way, so it's actually negative B plus EC, which is C. If you do not feel comfortable with the negative B being in front, this answer is perfectly correct. But if you want to write it, the equivalent answer is C minus B. Okay. Circuit breaker. Okay, it's actually the same thing. It's equivalent. Negative B plus C is same as vector C minus B. Okay, now I will now attempt to find the vector DA. Take some moments now, try to write out the vectors that are equivalent to D and A. So what two vectors can I use to get DA? The two vectors are DE plus EA. Alright, again, DA is this. So I started here, I ended here. The other way is I can move DE plus EA. I end off at the same point. So I can write it as DE is not D, is going the other way, so it's negative D plus A. Again, if you don't like the negative symbol in front, you can write it as A minus D. Okay. Now, hence show that A plus C equals to B plus D. So now let me just present the answer to you. Since A, B, C, D is a parallelogram, then AD is parallel to BC and AD will be equals to BC. So that means that vector AD and vectors BC are in the same direction. So I can say this, vectors BC is equals to vector AD. Do you agree? Because they have the same magnitude and they are in the same direction. So I will write it down as vectors BC is equals to vectors AD. Okay, but if what we actually found just now wasn't AD, what we actually found was actually the vector DA. So how is AD and DA related? They're the same magnitude, but they're going in different directions. So just want to show you something over here at the side there. Okay, so if I vector DA, DA can actually be rewritten, or rather, okay, so if they're the same magnitude but different direction, I can rewrite them as AD is actually the negative of the vector dA because it's going in the opposite direction. Hence, we have the negative symbol over here. So what I have here now is this. I have AD equals to negative dA. So back at the bottom, we have BC is equals to negative of the vector dA. So if I have BC is equals to vector C minus vector B, and negative of dA is down here, okay, or you can use this also, it's the same thing, is equals to negative D plus A. So I'm just transplanting this downwards. Okay, I just resolve the brackets. C minus B equals to D minus A. Okay, so therefore in this case, if vector C minus vector B equals to vector D minus vector A, so I can actually say that okay, how do we rearrange this? Okay, so basically, all right, what I can do here is this. Let me just use a highlighter. Negative A, if I bring it over here, it becomes plus A. Negative B, if I add B to both sides, it will become plus B over this side. So if I just rearrange, all right, I'll get vector A plus vector C is equals to vector B plus vector D. Hence, right, I actually have proven it, or I've shown that vector A plus vector C is equals to vector B plus vector D. Okay, just a few more examples before I conclude this part of 6.2. This is only just part 1 of 6.2. We will still have to do part 2 next week. So what we will begin here is this. Vector C minus vector D. I think I'll just do 2 for you. Okay, vector C minus vector D. So let me just draw it out. Okay, vector C is this minus D. Okay, positive D is going upwards, so therefore negative D will be going downwards. So this is negative D. So my resultant in this case is C minus D. Okay, let me just do 4B for you. C minus D. Okay, so if let me just redraw. Vector C is going this way. Okay, this will not be good. Let me just erase this. Okay, C minus D. I can just use this C over here. Is vector C minus D. D is going upwards. Hence, negative D will be going downwards like this. So C minus D. This will be negative D. The resultant is shown below here. This is vector C minus vector D. Okay, we are on question 5 on page 184. Alright, so now what I need is they want me to find OR minus OS. Very quickly, this is similar to what we have done earlier on in the topic. So if vector OR is this minus OS, if positive OS is this, negative OS will be going the other way. So let me just draw it out here. Okay, then my resultant vector will look like this. Okay, so this is my resultant vector over here. Now, what they need me to find is the magnitude. So again, if this 90-degree angle, this is also a 90-degree angle. Because if this is 90, I transplant it over here, this will also still be 90. So if I just apply Pythagoras' theorem, okay, what we'll get is the magnitude is equals to, this is 35 and 12. We have 35 square plus 12 square. Don't forget to take the square root, and the magnitude in this case is 37 units. Okay, this is finally the last question for today. what they want us to find is the vectors P and Q as a column vector. So I'll begin with vector P minus vector Q is equals to this minus this. Okay, simple computation, we get 0 and negative 2. Magnitude of vector P minus vector Q is simply equals to 0 square plus negative 2 square. Don't forget to square root. So what I get is 2 units. Alright, and thank you for watching the video for today. You may carry on to class